Okay, we're in section 3.2, variation. This is kind of a big section. There's a lot of stuff in here, so this will take a few videos to go through. But the first thing we want to talk about is, let's look at two different brands of paint, and we're going to compare these compare these outdoor paints. So comparison of outdoor paint. So we paint the side of a barn, bunch of barns, and we have these samples that we did. And maybe it's the same barns. We've broken up the side of the barn into different segments, and we painted these different segments with these different brands. So here's brand A. And what is happening is how long the paint seems to last in months. So brand A, so this is 10 months, 60 months, 50 months, 30 months, 40 months, and 20 months. So we have 6 different samples of this paint, and this is the months that those different samples survived. And then brand B, we have 6 samples of it also, and those 6 samples lasted 35 months, 45 months, 30 months, 35 months, 40 months, and 25 months. So let's go find the average number of months that the paint still looks good. So average value for each one of these samples. So if we look at brand A, what we want to do is add up all those values. So we're going to add those up and then divide by 6 because there's 6 samples. And we're going to do the same with brand B. So if you go add up brand A, what do you get for the total of these values? So I got 210. So we get brand A's average value, X bar, is equal to 210 divided by 6, which is equal to 35. Now let's look at brand B. Do the same thing. We're going to add up this total and divide by 6. And notice you get the same value, 210 divided by 6, or 35 months. So the average lifespan of this paint is 35 months for brand A or for brand B. But they look really different. I mean, brand A, it could go as low as 10 months or as high as 60 months, and brand B looks like their range is from 25 months to 45 months. So they don't look like the same type of paint. They obviously have different lasting abilities, and the question is how can they have the same average but be different this way? So that has to do what we call variability. So the difference in their variability is what we're seeing with these different values, even though the average value is the same. So if you want a really reliable paint, you want to be able to determine, in 35 months, it's pretty likely I'm going to have to go repaint this side of the barn, we would choose brand B. If we like to live more risky and you want to say, well, I have an opportunity for it to last 60 months, but that's just, 1 out of 6 times here that it did that, then you might choose brand A if you're going to be more risky in your behavior. So we want to be able to talk about this variability, and there are 3 measurements for this data spread or variability. So variability has to do with data spread, and there are 3 measurements that we're going to work with. Those 3 measurements are range, variance, and standard deviation. Now, Standard deviation and variance, those are both statistics, and they have a statistical variable associated with them and a population variable associated with it. So variance is what we call sigma squared. This is a population variance. And we'll figure out how to calculate this in a minute. S squared is the sample variance. Standard deviation is related to variance in that it is the square root of variance. So its variable is sigma for population standard deviation. Sorry, this symbol is sigma, and S for sample standard deviation. Now, in our book, and with most of the work that you would do with statistics, you're doing it with samples, not with populations. But I'm going to show you how to find the population variance and standard deviation, and then we're going to talk about sample, and that's what you're mostly going to use in your homework. In fact, that's all that you use in your homework. All right, so although we cover population, the sample variance and standard deviation is the typical measurement that you take with data sets, because you're usually doing samples. So before we get going, we're going to cover the range, and then we're going to go into variance and standard deviation for population and samples. So right now I'm going to talk about range because it's pretty easy. So the range is just the highest value of your data minus the lowest value. Okay, so if we looked at this data set that we had up here, like brand A and brand B, so let's look at brand A. The highest value is 60 and the lowest value is 10. So the range for brand A is 60 minus 10, or 50 months. And then we want to talk about the range for brand B. So if we go back up and look at our data for brand B, the smallest value or the lowest value in brand B is 25, and the highest value is 45. So if we go 45 minus 25, we get a range of 20 months. So already we can see that the spread of data is broader for brand A than it is for brand B, because the range is bigger in brand A than it is in brand B. All right, so the next thing we're going to do is look at variance and standard deviation. That'll be in the next one will be variance for populations and standard deviation for populations, and then we'll look at variance and standard deviation for samples. For samples.